This is the Flashforge Creator 5. It is a Core XY 3D printer that features a 4-tool changer, which means you can do not only multi-color but multi-material printing without all of the wastage that you get on a traditional color changing AMS style system. Now, today I'm going to be giving you my review on this printer, having spent some time with it. We're going to talk about its features and capabilities. I'm going to show you some of the results and at the end share with you my thoughts. Now, before we get into this, I just want to be clear in saying that Flashforge did reach out to me and send the Creator 5 over to me to take a look at for free. However, they've not paid me to make this video, and as always, my thoughts are entirely my own. Okay, so as I said, the Creator 5 is Flashforge's first tool changer printer. It's available in two models. You've got the Creator 5, as you see it here, and then the Creator 5 Pro, which is a fully enclosed printer and includes some additional features. Now, tool changers are very much the in thing at the moment, and it isn't because it's brand new technology that we haven't seen before. In fact, tool changers have been around for quite some time, but what has changed is how accessible they are, and manufacturers like Flashforge are now able to build printers with a tool changer for under $1,000. The real big benefits of a tool changer is the fact that you not only save time, but you save filament wastage as well. And each of those independent benefits add up to quite a lot. AMS style modules on printers actually work really well. They offer really good quality, no issues with color changing, but the problem you get is every time one of those units needs to change the filament, it has to cut the filament, draw it back into the AMS, push the new filament through, so that takes time, and then you have wastage as a result of the hot end having to purge that old filament out of the hot end every time it changes. If you were doing prints with, say, big blocks of multicolour, you wouldn't really see the downsides to an AMS module versus a tool changer. But when it comes to doing everyday printing where you're doing small models and the colour change is being done for very small amounts of colour, so as an example, eyes on a model, the time it takes to swap the filaments and the purge waste really does begin to add up, and in many cases you actually end up purging more of the colour you're changing to than you're actually putting into the print. As a result of that, this is where tool changers have a massive benefit, because this printer doesn't need to purge between every single change. It doesn't even need to swap the filaments. Instead, it swaps the whole tool head. You have 4 tool heads preloaded with your individual colors or materials, and they then are sitting there ready to be used and don't have the downsides that you have with pulling a filament out, swapping it over and purging it. Don't get me wrong, there is still some purging needed on a tool changer printer when you do things like calibrations, but overall the filament and time saving especially can be massive. In a recent review, I talked about the time difference between printing a multicolour model on the bamboo with an AMS compared to a tool changer, and the time difference was from about 13.5 hours down to just 2.5 hours, and that is as a result of it not having to mess around changing the filaments and instead simply picking the hot end with the filament preloaded. Now, the Creator 5 is Flashforge's first tool changer printer. It is a Core XY design, as you see it here. It features a 256 by 256 by 256 build volume, can print up to 600 millimeters a second, and comes with most of the normal features and capabilities you would expect to find on a modern day printer. The Creator 5 is the more standard model compared to the Creator 5 Pro. So this is a semi-enclosed printer is the term I would use. It's enclosed on both sides, however it has an open front, there is no door, has an open back, which means you can see straight through, and then it has an open top as well. That isn't to say you couldn't make this an enclosed printer if you wanted to, but it isn't designed to be enclosed from the factory. This printer features a 4 tool changer system. These are located on the left hand side of the printer as you see it up here. This printer is what I would class as a sort of tool or hot end changer. The main extruder assembly is located on the carriage at the top. This extruder assembly contains the extruder motor, and then each of the individual tools contains the drive mechanism, the feed mechanism for the filament, as well as the hot end assembly. It is a two-part system where the tools are magnetically held on pins on the left-hand side, and then the changer simply comes up, mounts on, grabs the hot end, and then it is ready to go. The way these tools are actually held onto the extruder mechanism is quite interesting. There's like a round collar with the drive shaft in the middle. The extrude assembly comes up to it. Some mechanism then grabs that collar and pulls the mechanism in, pulling the hot end tight to the extruder, and then it's able to move away with it fitted. To allow it to calibrate accurately, you'll also find that there's a metal pin permanently mounted onto the extruder. It actually uses this pin to calibrate the extruder assembly on its own, and then it will grab each tool head one at a time and then calibrate them with their hot end. And this is all done in the calibration area located under the build plate on the right hand side. The carriage assembly on this printer has two stainless steel rods, one at the front and one on the back, and the main rail for the extruder consists of a bent metal piece with a rail embedded in the bottom that the extruder slides forward and back on. The way they've decided to do this from an electrical perspective is, rather than mess around with things like pogo pins or wireless connectivity, you have a USB cable that comes over the top to the extruder, and then there are individual USB cables that go to each of the tool heads, which means you don't have to worry about wear and tear on pogo pins. All of the electrical items are permanently connected, which means it should offer some really good reliability. When it comes to the printing performance, it can print up to 600 millimeters a second. Each of the four tools comes with a 0.4 millimeter hardened steel hot end, which can print up to 320 degrees C. The bed, as I mentioned, is 256 by 256 by 256, can heat up to 120 degrees, and features a sprung metal PEI removable sheet. This is held in place by a little sort of plastic area at the back that allows it to sit in place nicely. There's a magnetic pad underneath, and also underneath the sheet as well is a little calibration area for each of the tool heads. When it comes to cleaning and purging, rather than there being individual wiping and cleaning areas for each tool head, instead each tool head sits in its parked position with a little rubber pad at the bottom that prevents oozing, and you then have a single wiper area located on the right hand side of the bed at the front. There is no bucket or mechanism to collect any of the purging. What the printer actually does is when it purges and wipes off the right hand side, and that simply falls to the bottom of the printer down there for you to grab and put in the bin. On top of all of that, it has the usual capabilities like input shaping calibration, flow calibration, to ensure that you get the best possible results from the print. Now, when it comes to controlling this printer, it features a 4-inch color touchscreen on the front with a resolution of 480 by 800. That built-in screen is also articulating as well, allowing you to tilt it up and down. The UI the printer has is fairly simple and straightforward. You have a home page with all of the basic information on the current printer's status. You've got a dedicated page for your prints, your filament control, as well as the printer settings. It also has built-in Wi-Fi, allowing you to be able to control the printer via the app as well as their slicer, and it also has a built-in webcam with a 1280 by 720p resolution at 30 frames a second. To be able to print, Flashforge have chosen Orca Slicer as the base for their slicer. This is called Orca Flashforge. That allows you to send prints either directly to the printer via the Flashforge cloud service, but this printer also has a LAN mode built into it as well, allowing you to send the prints locally on your network, completely disconnecting it from their cloud service. You do also have a USB port located on the right hand side, allowing you to export your time lapses as well as upload prints directly. When it comes to loading and unloading the filament on this printer, it is all very basic. There is no automatic feeding here. There is no RFID detection. You simply need to place your spools on the holders at the side. You manually then feed it through the PTFE tubes down to the extruder. On each extruder, you will find that there is a manual filament cutter lever. This printer doesn't press that up against anything to cut automatically. When loading, you'll need to push it in so it goes down to the gears. And when it comes to unloading your filaments, it's simply a case of pressing the lever on the side to cut the filament and then pulling it back out the PTFE tube. In the menu system, it allows you to configure the filaments for each of the hot ends. You can tell it the filament type as well as the color. As I mentioned though, there's no RFID, so it will not detect it automatically. And unfortunately, there is no way to tell it to load each of the filaments together. So for instance, if you're swapping one spool of filament, it's fine. You can tell it that you've swapped it and it will purge and extrude. Whereas if you've changed all four, unfortunately, you have to tell it to do it one at a time. It'll do the first one, then finish, then go back in the menu, tell it to do the second one. What you can't do, unfortunately, is tell it to do 1, 2, and 3, and 4 sequentially without having to do it manually one at a time in the menu system. Hopefully, this is something Flashforge will be able to improve in the firmware in the future, because it does make loading and unloading multiple filaments a little bit time consuming. As I mentioned, when the filament loading process takes place, it will purge that filament and wipe it on the right hand side of the bed, and that will simply drop down to the bottom area below the bed on the right hand side. I'm going to probably 3D print a bucket or something for this because it is a little bit messy. Looking around externally and talking about the build quality, overall it's actually pretty good. It is a mixture of materials. This top section around here is metal, so this is actually metal for the Core XY system. That's the main spine and structure of the printer. You then have plastic internals and side panels, but there is a metal spine within that. You've then got your carriage assembly, which is stainless rods. You've got that bent metal rod and rail in the middle. You've got your bed assembly, which is a mixture of materials, your sprung metal sheet, a magnetic sheet under it, and there's some metal in there for the heater too. 3 worm screws and rods for the bed, and then you got your filament holders over there. Overall, it doesn't feel the best and it doesn't feel the worst. It really is what you would expect for a printer of this price. When it comes to being able to obviously fit this in your workspace, you are going to need to take into account that it's going to need space on that side. I quite like the fact that they've chosen to put all the spools on one side as well, rather than mixing between the two, because this side can go up against something. It's fine. The back as well is because you've got nothing here. You are going to need to leave some space because the filament spools do stick out beyond the front and the back of the printer, so do take that into account. But what it means is you shouldn't need to pull the printer out to be able to get to everything, and really the area where you're going to need the most space is on that side there. I can actually see some people wanting to put this printer with this actually going against the wall side on, so you just reach round to the side and bring the bed in and out and have them facing outwards, giving you complete access. But yeah, overall no major complaints on that side of things. A couple of other little observations. When it comes to the cooling system on this printer, there is no auxiliary parts cooling fan, but there are internal cooling fans for the electronics. That isn't something we always see from all of the manufacturers. You can hear it when you power the printer up. There is definitely cooling fans in the electronics there, which means it'll keep the motor drivers under temp control, which is good to see. When you get this printer, you are going to need to set it up, and there is some mild assembly needed, but I have to say Flashforge have done a great job on doing as much as they can for you. I'm not going to go over the assembly too much in this video today, but the very basics are all of the tool changes. That whole mechanism comes pre-assembled from the factory. That simply clips into the side of the printer, a couple of screws to hold it in place. You then simply need to release the bed from the base with a couple of screws, mount the screen onto the front with an edge connector, and that is pretty much it. You do need to also mount the filament holders on the right hand side, and just note you do need to make sure you do mount them the right way round. I actually got it wrong the first time. I'm probably going to release a separate video on the assembly of this printer, but overall, just to say more than anything that it is fairly simple and straightforward. Really is no more than half an hour, 40 minutes. Once you power it up, you will then need to go through the process of registration if you want to use the app, perform all the usual calibrations like input shaping, the calibrations for the tool heads. That's all going to take about an hour, giving you probably 2 hours roughly from naught to finish before you're able to print. Here, just to demonstrate this tool changing behavior, we're currently printing one of the multicolour benchy prints that's included with the printer as a test. It is multicolour, as you can see on the display there. And what I want to just show you is this tool changing behavior. It is really quick and simple. There's no wasted time on this. It automatically knows what tool it's going to use, when it's going to change it, and it'll even do things like preheat the next tool ready for use. So at the moment, we're currently using tool number 1. You can see there the others are waiting. If we just come back and look at the display, you can see there that the other tools are currently sitting at 37, 36 degrees. And the hint that a change is coming up will be when you see one of these other tools start to warm up. It doesn't really give you much time. It will literally kick that second tool in pretty quickly and then do the switch. At the moment, the other 3 are all at the same temperature, and it won't be long now before we should be getting ready for another switch over to another color. There we go. It's warming the other tool up, so I'm going to get ready. Hold the camera here. The other tool's at 108 degrees, and what you're going to see now in a moment is it park. There you go. Pick up tool number 2. It will then do a quick check, and it does take longer the first time it switches compared to other times in the switch process. So as an example, if you were changing multiple times, you'd find the multiple exchanges actually would happen quicker. And you can see that's it there. It's now swapped over to that tool. So we've gone from tool 1 to tool 2. The other tools are now sitting at the temperature, and you can see we're on the orange. And what it's going to do then is continue, go through the print, get ready for the next swap, and carry on. Okay, we're getting ready for the next swap. You can see tool number 3 is warming up. So if we come up, you can see it's going to swap over to the next one. And then again, nice and simple, straightforward, short pause. It'll then put a little bit into the prime tower, and then it'll carry on. No wastage, a little bit of time, much faster than you would have on an AMS. Here, just to show you the tool changing on something a little bit more extreme, I've taken a calibration cube and I have changed the colors of each face as well as the lettering inside. If we then take a look at this in the preview, you can see we have the multi-colors. And if we have a look then the internal structure, we're going to see a lot of tool changes on this, a lot of different colors, a lot of different positions. This is saying it's going to take an hour and 36 minutes, but what it will do is give us a good demonstration of all of the different changes in action. Before you send the file to the printer, it is going to ask you to select the color order. So here you can see the 4 colors that I've got selected in the slicer, and then we can assign them to the colors on the printer. I've done this to match, but you can do this in a different color order if you wanted to. You don't need to match them up exactly. There is a link between the colors, but you do have the ability to completely manually override this, and you could choose 1 to go to 3, 3 to go to 1, whichever order you want. On this, we're not going to do leveling or flow calibration. We're going to simply leave all of them off, and then we're going to click print. Just to demonstrate the massive difference a tool changer makes in both time saving but also filament saving as well. Here, that cube is sliced for the Flashforge. You can see it is going to take 1 hour and 37 minutes to print. We're going to use 5.73 grams of filament on the model itself, 16.21 grams on the prime tower, which gives us a total of 21.95 grams. Because this is such a small model, we are going to use 3 times as much filament on the prime tower as we are the model itself, but it is still only 21 grams. If we then compare this to exactly the same model sliced on the Bamboo P2S using the AMS module, it is exactly the same color scheme. You can see that time has now increased to 7 hours and 54 minutes. That time increase is just the amount of time it takes to swap the filament back and forth on the AMS module, but it's more than that. If we look at the filament usage, our model 5.77 grams, so very similar. However, now we have 104 grams of filament being used on purging for our filament swaps, 13 grams of filament being used for our prime tower, which gives us a total of 123 grams, 6 times as much filament compared to what is being used by the Flashforge. Again, 21.95, 1 hour and 37, 123.49, and 7 hours and 54. This is the sheer difference a tool changer makes as a result of not having the time wasted as a result of swapping the filaments, but not having to purge that filament as well. Okay, so the next thing we're going to do is take a look at some of the print results that I've had from this printer. I'm going to show you some of the time lapses that I've taken from the onboard footage, and then I'll give you a bit of an overview of the results and then share with you my overall thoughts on this printer. We're going to talk about standard prints here, and then we're going to talk about flexibles, because there's certainly some stuff there that you need to be aware of. Now, first of all, I just want to show you some of the time lapses that we've got from this printer. This has been recorded on board directly. As you can see, the resolution isn't particularly high. These record in 640 by 480 at 10 frames a second. The overall camera behavior is okay. It's quite low resolution overall, whether you're watching that on the time lapse, whether you're looking at it in the slicer or via the Creator 5 app. And again, it does its job, but it isn't the highest of resolution cameras that I've seen on printers. Here, I just want to show you the results of a full bed print test. This is a 0.2mm sheet. It is just finished. Just to show you from above, overall, it looks pretty good. I'm not going to say it's perfect. I am seeing some gaps up here, which I suspect will string a little bit once we try to remove it off the bed. But I'm not really seeing any high spots, which would indicate that the bed level itself has done pretty good. But you can see by here just a few areas where it looks a little bit stringy. If we just now peel it off the bed, you can do that peel. Let's see how it goes. Actually, no, it's held up. That's pretty good. That is pretty good indeed. Now, when it comes to prints and the quality, rather than sit you and show you 20 or 30 prints, I'm going to just show you a selection of prints that I've done and share with you my opinion on the results, rather than show loads of different things. But I have a few I do want to talk about. Now, as I did show on that bed test, that is the sheet there. Overall, I'm pretty happy with it. A little stringy down here. It's close enough. It's not 100% perfect, but it's certainly pretty close, and I think it's going to be absolutely fine for most people. Now, I did a couple of very basic benchy tests. These are done really just to show you the overall print quality and colour separation. Here is a pure green print benchy. You can see the bottom layer looks absolutely fine. You can see a little bit of area around there on the bow that typically shows an issue, and that's the case here on a fast benchy as well, as you get the change in speeds for the bow of the boat as we move towards the flooring. Text on the back is pretty good, not perfect, but pretty much what I would expect from most printers. And here is a multicolour typical benchy. You can see there the colour definition between the layers is really nice. No bleed over. Really quite a clean print overall, actually. So again, it's a nice demonstration of what the printer is capable of doing. Top and bottom layers look really decent. Top layer nicely, no gaps. So everything is sort of doing what we would expect it to do. From a basic color printing perspective, it's doing a decent job. Moving over to this little dragon print. Now, this is the same one that I did on the Snapmaker. That's it there in red, yellow, black, and white. And then here I did it with the Flashforge filaments. Overall, the quality is actually pretty good, but there are a few little errors in the print that I didn't get on the Snapmaker. Nothing phenomenal, but you can see it there on this left eye. The right eye looks pretty good. The left eye has just a couple of areas where it didn't quite fill in properly. The separation between the blue and the purple and the quality on the blue is perfect. It's really nice. You can see that textured skin has come out really well. The bottom layer, the definition between the orange toes and the blue on the top and the bottom is really good. Overall, it's a really nice print. It just got let down by two areas on the orange here and here on the eye. I didn't get that on the Snapmaker, but that isn't to say if I didn't do a second print on this, it wouldn't look as good. But overall, it's a pretty clean print, other than those few little errors. I then proceeded to print some coasters, which are Deadpool themed. Now, I did these on the printer. I did several of these, actually. I've done one where it's double-sided, and then I did 4 of them, which were single-sided. So these were printed with this side down. And whilst the print side is perfect, there were some issues with it lifting and then catching around the ends on some of the print. If I show you on this one, you can see it there. We've got some roughness around here, and they didn't stick to the bed fully, and as a result of that, there's a rounding effect on the edge there. If I just try and tilt that, the edge falls off where it is lifted off the bed, and then that's resulted in this edge not quite being 100%. To be fair, when you place it down, it looks absolutely fine. The color definition between the colors is pretty good. Again, on this one, a little mark there on the white. This one is a little bit better. You can see the layer lines, but a lot of that is taken out by the texture on the build plate. That helps to hide a lot of that. I think they're okay. I'd need to try and figure out how to tag them down a little better. Really, I wouldn't blame that on bed level. It's just the lifting as the print started to curl up around the sides. Now, the most complex print I have done on this printer is this, and this is a Hulk. Now, let me zoom out a little bit so we can get him fully on screen. I printed this in one hit on the printer. Obviously, it is a multi-color print, so we have the green, the purple, the black, and then the white. You can see he is missing a tooth. That has been caused by me trying to remove the support material. The support material was a bit of a pig to get off this one. But as you can see, overall, it has come out very nice. The definition on this is really quite clean. It was printed at 0.0, I think it was 0.012 I printed this at. The hair has a nice spike to it. The definition on the face is good. The overhangs are good, even where we had the support. And then under the arms, no loose filament. You can see there where we've gone to the support material. You can see that. But overall, it has come out pretty good. The only thing I will say is there are areas where some of the other colour, you get traces of it. If you see it here, it's on the back of the print there. If I just zoom in, you can see that there on his back. There are areas where the infill, where the changing of the print leaves some marks. And to sort of show you this in a bit more detail, here is the wipe tower for that print. And you can see that here. You do get a bit of this sort of fluff, this wispiness appear from the print. And I've noticed this on most prints. This will be partly being driven by how wet the filament is, retraction settings, all the usual stuff that come into play with this. However, I am seeing some bobbling, some bits as a result of the wiping mechanism. This filament was dried, however I am still getting the stringing happening, and I'm also getting it on some prints I wouldn't expect to get it on with dry filament. Again, it isn't a specific one cause issue. It can be caused by many things, wet filament, retraction settings, but what I have noticed looking at times watching the printer, that there is oozing, there is a build-up of filament around the hot end as well that is being driven by this lack of wiping mechanism for each tool head. The overall print quality I'm really happy with. It's just that there is some work to be done, I think, on the behavior between the color changes. I personally think the printer would be better also wiping the nozzle between every change as well. Again, this is going to add time and it is going to add complexity. I don't think the wipe tower is enough to completely clean the nozzle, and you do start to see at times the filament building up, especially when I tested it with flexibles, but I will talk about that separately in a minute. Okay, now when it comes to flexibles, unfortunately, things are a little bit different. And in fact, I don't recommend you consider this printer for flexibles at all at this moment in time. I have not managed to get a successful TPU print out of this printer. In typical 95, I'm getting either the print comes out a complete disaster or it jams up in the extruder. For instance, using same smart filaments as well as some overture filaments. On the overtures, especially, the blue will print but it's horrible. The orange won't even print. It keeps getting jammed in the extruder. Having spent some time looking at this and had many extruders get jammed with filament, I think the spring tension mechanism is too tight on this extruder setup. When you look inside this extruder, the way it's actually done is that the blade cutter mechanism is linked to the tension mechanism on the filament, and as a result of that, the spring tension is a little bit too much. I'm gonna have more of a play on how I can sort of improve this. I've got some ideas to try and reduce the spring tension, either by changing the spring, was suggested to be by one of the guys on my Discord, or something that you can sort of mount to sort of take the pressure off that lever slightly. Maybe a redesigned 3D printable lever. However, the reality is right now, as it comes from my testing, filaments such as TPU95 are a complete no-go, and you should consider other options if you are looking for a tool changer with TPU95 support. Just to show you this in a bit more detail, I'm just going to give you a quick overview of the inside of the extruder and show you me actually tearing one down that had jammed up. Okay, so when it comes to tearing this down, it's fairly straightforward. There are 4 screws. You've got the 1, 2, 3, and the 4th one here next to the lever. It's these 4 black ones that hold the 2 halves of the cases together. Okay, so I've just removed the screws on this one, and I'm gonna take it apart. We're gonna very carefully undo the fan connection at the top there, so that will give us good access to the whole of the inside of the extruder. And there we can see filament has got coiled up. This was the very first print with this TPU. This is 95. It is Overture. It is fairly soft, but nonetheless it is still 95. So we're going to now need to figure out how we actually get this out. Is that a nut there? Let's just have a look. Yes, that appears to be. So if we unscrew that, okay, so that looks like it's the pivot pin, and there we go. We can now withdraw the filament. No damage from the look of it. So it did feed. It's pulled back because I was trying to pull it out from when inside. There you can see the filament cutter blade. So if you did need to replace that, that is there as well. So what I'm guessing is that goes into there like that. So when you do a pull, it pulls that way to cut the filament. So all we should now need to do is pop that back there, put a bit of pressure on it with my finger to get my screw back in place, try and get this in the right spot to be able to tighten. There we are. There we go. That's the lever back in place. So it's not a shocking job being able to unblock it, but yeah, not ideal on the first attempt. Okay, so to share with you my thoughts on the Creator 5 from Flashforge, and I'm going to separate this into a couple of areas. Obviously, you've got the printer hardware itself, you've then got the tool changer and the software, and there is no question to me this printer is a bit compromised in several areas. It is a budget tool changer, and there are things it does really well, and there are things that it somewhat doesn't. The good news is a lot of the pain points for me on this printer can be improved in software. Not all of them, but many of them can. From a hardware perspective, I actually have very few complaints. The printer is well built, the top metal thing, the structure is solid. Yes, it doesn't have carbon fiber rods, but I don't see anything here that I think is going to be a reliability issue over time. I actually think what they've done is really good. The tool changer system seems to work very well. I've not had a single tool change failure. It has been perfect. Where this printer struggles a little bit is where they've cut it back. There are elements around this that feel like they could have done things better in the hardware. The wiping mechanism, for starters, the fact that you do get the spider's webs on the print, it needs to start wiping between tool changes more to try and keep that nozzle clean. There is contamination between the colours at times as a result of contamination on the tool head, not the printer functionality itself. This wiping mechanism and the filament purging when it does change a filament is a bit naff, if I'm honest. The fact that it just dumps it down the front of the printer here, it feels like it wasn't thought about to the very end. It's not end of the world, but I would have expected something better from a 2026 printer, and I think they need better wiping mechanisms for the tools. It does have that little rubber area under the nozzle, but that isn't a wipe. It needs a better wiping mechanism. But the good news is I think there's stuff users could do here around this to be able to improve it. You could certainly do a few modifications around adding like brushes on the end. I think when it comes to this wiping mechanism, there is an opportunity for community-driven improvements more than Flashforge being able to do much. Don't get me wrong. The fact that those little rubber things clip in means that they could swap them out and offer something better. It's not that it's terrible, but it isn't fully living up to its potential in that regard. When it comes to software, there are elements of this printer that are painful. The fact that you have to load the filaments one at a time. The good news with this is this can be done, improved in firmware. The fact that you have to go do that one, then do that one. Flashforge, please add the option to be able to load all of the filaments or choose which ones you want it to do and load them in and just say, can you go and do 1, 3 and 4, 1, 2 and 3. Whatever option we want would be brilliant. And again, there are just little bits of the firmware that are a little bit quirky in that regard. You do also see the quality element a little bit in things like the live view camera isn't great. Even on the app, the time-lapse footage is very low resolution, 640 by 480. There are elements of this that are stepped well behind what other manufacturers are offering, but they're giving you something more through having that tool changer mechanism. Positives are the fact that the tools seem to be very reliable and they're also easy to take apart as well. That was nice to see. But when it comes to printing, I have to say I am disappointed in the fact that flexibles does appear to be a no-go here. I need to spend more time on this. I couldn't wait any longer to get this video out the door. Right now, just don't go near this if you're looking to print TPUs. It just doesn't play ball for me at all. At least it doesn't play ball without modification, and that is something we're going to have to look at separately later. Overall, the Flashforge Creator 5 is a budget tool changer printer, and they've done a lot of things good, and the majority of that is hardware. It isn't perfect. There are improvements needed in the software, but if you're looking for a tool changer just to be able to do things like you see in front of me here, I think overall you'll be happy with this printer. I think there are improvements that Flashforge need to make, and the majority of them are in the software. So the good news about that is you might get that in the future as well. But it does a good job. It sits in a bit of a weird position because to be frank, there are things that the Snapmaker U1 does better than this. There isn't really much here that this does better than the Snapmaker U1. It is a different printer to what Bamboo are offering, but I think it is certainly an option for people who are looking to get a tool changer printer and have this price point in mind. As long as you stick into things like basic multicolor PLA prints, you're not worried about flexibles, I think you'll be happy with this printer. So that's my thoughts. Now, I hope you have found this information useful. Let me know what you think down below. If you'd like to support the channel to allow me to keep making content like this in the future, please do consider checking out the links to my Patreon as well as buying me a coffee. Finally, I'd also just like to say a thank you to Flashforge for sending this one over. Let me know if there's anything I've missed. Stay safe, and I will speak to you soon.